Hello, Lady A here, and in today's episode, we'll be discussing the Juno space mission, a bit about its origin, its namesake, and more. So, relax and pop in an earbud or a speaker as we explore the heavens explorative queen, Juno. Every king needs his queen, and that is no more true than in the Roman pantheon, with the god and goddess, Jupiter and Juno, king and queen of the gods. Juno is the Roman goddess of marriage and childbirth, whose Greek counterpart is Hera. She ruled over the gods with her husband Jupiter, and was seen as the protector of young women. While typically depicted as graceful, especially in her Greek counterpart, Juno was actually more warrior-like, often seen carrying a staff and a shield. Now, why am I talking of a Roman god? Well, that's because Juno is the namesake of today's topic, the Juno mission to Jupiter. It has always been believed that giant planets, made of mostly gas like Jupiter, are crucial in understanding how solar systems and planets formed. As such, NASA decided to launch their first mission to explore Jupiter thoroughly through the Juno space mission. Especially since Jupiter has elements such as carbon and nitrogen, which are very similar to what stars are made of. Juno had many goals to accomplish in her prime mission. These included searching for water, plunging into Jupiter's depths, exploring the magnetic field, and much more, to see what really makes Jupiter tick, could it have life, and its place in the solar system in telling us how solar systems, planets, and stars are formed. To do so, Juno was equipped with various instruments. These include gravity science, magnetometer, microwave radiometer, Jupiter Energetic Particle Detector Instrument, Jovian Auroral Distributions Experiment, waves, ultraviolet imaging spectrograph, Jovian Infrared Auroral Mapper, JunoCam, and a Stellar Reference Unit. At the time predating her launch, not much was known about Jupiter. For example, it was believed that it was a solid core with much gas around it, along with a poor understanding of how its magnetic field works. August 5th, 2011, at Cape Canaveral Air Force Station, Florida, Launch Complex 41. The Juno spacecraft was launched into space to make her 1.7 billion mile journey to the planet Jupiter. This would take a while, as in 2013, a gravity assist was used with Earth to ensure that she would build up enough speed to make it to her destination, which she finally reached on July 5th, 2016. Once she made to her destination, she settled into a 53-day polar orbit. During her prime mission, she made 35 elliptical orbits around Jupiter, collecting over 3 terabytes of data, and at the time of writing, she has been up there 5 years, 10 months, 2 days, 21 hours, 11 minutes, and counting. But of course, by the time you hear this, it would be closer to 3 or 4 days, or even longer. Solar powered and the span of a basketball court, Juno was well equipped to be able to handle and be able to be energized during its orbit. Thanks to Juno, Science made many discoveries, but here are the top 10. Water mystery solved. In 1995, a probe by the Galileo spaceship was dropped into Jupiter's atmosphere and found that it was very dry. It was believed that maybe Jupiter's atmosphere had much less water than expected. However, thanks to Juno, it was discovered that water is simply more abundant near the equator of the planet. New cyclone. During one of its many flybys, passing less than 2,200 miles above Jupiter's clouds, Juno dodged Jupiter's shadow to avoid freezing. Then it discovered a giant cyclone at the planet's south pole, a pattern of 6 cyclones with one in the center, and seemed locked in place. But somehow, a new cyclone had developed and joined the group. And this was discovered in December 2019. Number 8. Lightning. Previous spacecrafts, Voyagers 1 and 2, Galileo and Cassini, found that in the storms of Jupiter, lightning was quite abundant, much like radio noise. However, unlike Earth's lightning, Jupiter's can only be found on lower radio frequencies. And in June 2018, Juno picked up a much higher frequency of lightning as well. Probably thanks to it being closer than the previous spacecrafts. As such, it resolved the many mysteries of Jovian lightning. 9-storm North Pole. Jupiter is well famous for having many storms, such as its infamous red dot. However, at its North Pole there exists 9 storms, a central one surrounded by 8 smaller ones, ranging from 2,500 to 2,900 miles across. These storms do not merge, however, and stay locked, orbiting each other. A great red spot. The most iconic storm of Jupiter, as stated previously, is the Great Red Spot, or dot, depending on who you ask. It has been active and swirling for many centuries. However, it is seen that it is slowly shrinking with time. It was found that in 1979, it was twice the size of Earth. However, in December 2017, it was found to be 1.3 times the size of our planet, showing signs that it is shrinking relatively steadily as time progresses. Number 5. Jolts from the poles. As I have stated previously, there are many storms all over the planet, such as the 9-storm of the North Pole. Many of these storms also produce the previously mentioned Jovian lightning, forming auroras at its respective poles. However, Jovian lightning, since the planet is much bigger, reaches much higher voltages than those on Earth, the most powerful of which being 400,000 electron volts. Number 4 can be ranked alongside number 5, as this also refers to storms. Jupiter is just a planet of a lot of storms, that being its main selling point. So onward we go to number 3, Jupiter's beltways. The various clouds on the planet form belts or zones all over it, which can be seen from Earth if your eyes are good enough or there is lack of light pollution in your area. Near the equator they are quite steady in shape, being bands. However, as you move towards the poles they tend to change into other structures. Number 2. Outstanding in its field. One of Juno's main goals was to look at and explore Jupiter's magnetosphere. As seen through its discoveries, Jupiter's magnetic field is 10 times stronger than that of Earth. And finally, at number 1, thanks to Juno, science was able to get its first glimpse of the North Pole of Jupiter, which previously had not been seen or known. However, it was also discovered that unlike its cousin Saturn, which has hexagonal jet streams at its north poles, Jupiter does not. On August 1st, 2021, just mere days before Juno's 10th anniversary, NASA announced that it would be extending Juno's mission until September 2025 or until the end of the spaceship's life. If the latter happens, then much like Cassini and Galileo, it will enter the planet's atmosphere before burning into a crisp or being crumpled into oblivion. In its extended mission, Juno will orbit past Io and Europa and conduct studies on Jupiter's rings, because much like Saturn, Jupiter and the other gas giants of our solar system have rings. There are many online resources one can use to learn this, and there's also a 3D model available on NASA's website so you can explore and see her for yourself. And just explore what this strange windmill blade shaped spaceship is really capable of and what it has accomplished. The links to these will be included in the description for today's episode. And that concludes today's episode, The Heavens Explorative Queen. Join us next week for the next episode, Helios's Failed Stellar King, where we look at the planet Jupiter, the largest of our solar system, and one of many failed stars in the universe. Why did it fail? What is it made of? And what would happen to our solar system if it somehow did become a star? Join me next time to find out. Take care, and remember, the universe is the greatest archive, and you are the stardust that makes it special. Thanks for listening.